Okay, 5.2 properties of exponents and radicals. We're going to do a quick review of them. Okay, so for example, when we're going to simplify the radical, on the third root of 875, if you want to double check it in your calculator, it does not come out evenly. Okay, but we want to see if there's any perfect cubes that divide into 875. So most people did a factor tree. Okay, for 875, I have no idea what divides into it, but it does end in a 5. If it ends in a 5, it will divide by 5. So I'm going to do 875, and I'm going to divide it by 5 on my calculator. I got 175. Okay, the 5 is prime, but the 175 can go further. Okay, 175, if you have no idea what it divides by, you could divide it by 5. I can divide it by 25 because I know that I can pay 175 in quarters. Okay, the 7's prime, but now we're going to go 5, 5. Now when I look at the factors, I'm only looking at the end. So I'm looking at this, 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 and this. Since this is a third root, I'm looking for 3 of the same factor. Okay, so I'm going to show the middle step, but some of you skip to the final step. Okay, so the factors that are left are I have 5 times 5 times 5, which is 5. And then I have 5, 5, 5. I have this extra 7, so I'm going to put the 7 over here. Okay, now if I do the third root of 5 to the third, I get 5. The third root of 7 is irrational, and I don't know what it is. So it's 5 times the third root of 7. Okay, look at B, and then go ahead and try that on your own. Unpause when you're ready to check your answer. Okay, I did my factor tree. Since this is even and I had no idea what to use, I used 2. Okay, I highlighted all my leaves of my factor tree. Since this is a fourth root, I'm looking for something to the fourth. So 1, 2, 3, 4. Okay, I'm going to show the middle step. Some people skip this step. Okay, so I have 2 to the fourth. What else do I have? I have the 3 and the 2. 3 times 2 is 6. Okay, so the fourth root of 2 to the fourth is 2. The fourth root of 6 is irrational. Okay, now what about when we have variables? Okay, let's remind ourselves. Remember, if I have the fifth root of m to the fifth, I know that that cancels. So I'm going to go ahead and take the m out. Okay, now if I have the fifth root of n to the seventh, since n to the seventh is more than n to the fifth, I can for sure take out an n. Okay, so I canceled out n to the fifth. How many n's are left? N to the second. Okay, now when I get to p to the 4, p to the 4 is not as high as p to the 5th, so there's no way I'm going to take it out. So I'm going to leave my answer like that. Okay, let's look at D. D's going to put it all together. Okay, why don't you pause and try it. Okay, I'm showing my setup and my middle step. Some of you show this and some of you don't. If you don't show this step, do show your factor tree so I can see that you got the answer. Okay, if I do the third root of 3 to the third, I get 3. Okay, the 2 is going to stay in. If I do the third root of x to the third, I get x. Let's take that out. What else do we have? The third root of y to the third is y. And if I do the third root of z to the third, I get z. And if I do it to this one, I get another z. So I get a z, but I get another one, so z squared. Everything else is going to stay inside. So what am I left with? I have the 2, the x, and that's it. Okay, now let's look at properties of exponents. Okay, so for A, I have 7 to the 5 halves times 7 to the 1 half. Since they have the same base, I can add the exponents. 5 halves plus 1 halves is 6 halves. Okay, if the fraction simplifies, let's simplify it. 6 over 2 is 3. So 7 to the third, I'm going to punch it in my calculator, and I got 343. And you can use your calculator for the arithmetic, but do show your steps for the algebra. Okay, B, 6 to the 2/3 times 6 to the 1/3. And the parentheses don't make a difference. They're just telling you the base is 6. Since they both have a base of 6, I'm going to go ahead and add the exponents. 2/3 plus 1/3 is 3/3. 6 to the 1 is 6. Okay, for C, 10 to the 8/3 divided by 10 to the 2/3. Again, same base. If it's the same base, I can do something with the exponents. Since it's a fraction, I will subtract the exponents. So 8/3 minus 2/3 is 6/3. 6 divided by 3 is 2. I get 100. Okay, 8 to the 2/5 raised to the 5th. So in this case, I'm raising something to another power. And when I do that, I multiply these exponents together. Okay, I'll show you 2 ways to do it. Okay, one way to do it would be to say, okay, this is 2/5 and this is 5/1. If I do the top numbers, the 2 times the 5, I get 10. If I do 5 times 1, I get 5. So I'm going to get 8 to the 2nd, and I'm going to get 64. Okay, some people like to cross cancel, which is also fine. If I do 2/5 times 5, some people go, okay, well, if there's a 5 on the top and bottom, it's going to cancel right away. And then it goes 8 to the 2nd, and I still get 64. So if it's convenient, go ahead and cross cancel. If not, you can always multiply it out. Okay, let's distribute the 1/3. So that's 27 to the top to the bottom. Okay, now if these had been dividable, I would have divided them, but they don't divide. So what is 27 to the 1/3? It's the 3rd root of 27 over the 3rd root of 125, which is 3/5. Okay, F. Let's see. I could multiply these together, but I'm going to get a ginormous number. So let me distribute the 1/3. So 64 to the 1/3. 25 to the 1/3, and that's an exponent. Since it's a fraction, it's a 3rd root. 3rd root. So what is that? 4 times 5, 20. And we're just trying to make these easier to evaluate. There could be more than one way. Okay, let's get to the tricky row. Okay, 5 to the 4th times 9 is going to be very, very big. So let me see if I can distribute the exponent instead. Okay, so if I do 4 times 1/2, you can do it in your head, or you can do it on the side, or you can do it with a common denominator. 4 times 1/2, what is that? 4 divided by 2, I'm going to get squared. 9 to the 1/2. What's 5 to the 2nd? 25. What's 9 to the 1/2? Oh, that's the square root of 9. So this is 25 times 3, so I get 75. Let's try another tricky one. Okay, 2 to the 6 is pretty big. 8 to the 1/2 is the square root of 8. I don't even want to do that. So let's try to use the properties. Okay, so for the top, if I do 6, I'm going to times these. 6 times 2 is 12. 1 times 3 is 3. Okay, what about on the bottom? 8 times, what do I have? Let me write this out. 1/2 times 2/3. Yeah, let's cancel those 2's to make it easier for us. 1/3. Okay, let's see where this takes us. We have 2 to the 4th. What's 8 to the 1/3? Well, that's the 3rd root of 8. Okay, 2 to the 4th is 16. 3rd root of 8 is 2. So my answer is actually 8. Okay, one more exponent. Okay, I have the quantity 8 to the 1/3 times 2 to the -2, and it's all raised to the 0. Now I can distribute this 0 if I want, but I should recognize that anything to the 0 power is going to equal 1 anyways, and I can save myself the trouble and just write the answer. Okay, now we're going to use properties of radicals to simplify. Okay, 5th root of 16 times 5th root of 2. Now if I knew the 5th root of 16, I would just evaluate it. Since I don't, and since they're both 5th roots, let's multiply them together and see if it'll make it easier. 16 times 2 is 32. Do we know the 5th root of 32? Yeah, it's 2. Okay, so I only multiply them if it's going to make it easier. Now if I do the 4th root of 80 divided by the 4th root of 5, do I know either of those answers? No. If I knew them, I would evaluate them. So let's divide. Since they're both 4th roots, 80 divided by 5 is 16. The 4th root of 16, that is 2. Okay, what is this, subtraction? 11 times the 3rd root of 2x minus 5 times the 3rd root of 2x. I'm subtracting. Are they like terms? Yup, because their radical and radicand is identical. So 11 minus 5 is 6. 3rd root of 2x's. And that highlighted part does not change. Okay, D, 3rd root of 375 plus 8 times the 3rd root of 3. Are they like terms? They don't look like it. but that 375 is so big, it probably simplifies. Okay, since it ends in a 5, I'm going to do 5. You can start out with any combination that works, but since it ends in 5, I start with that, 75. Okay, 75 is 25 and 3, or it ends in a 5. You could do 5 again if you can't think of a number. Okay, 15 is 5 and 3. Okay, what are we doing? Third root. Let me look at the leaves. Okay, I have 3 5s, so I can take the 5 out. If I take the 5 out, I'm left with the 3. Okay, are they like terms now? They are. So 5 plus 8, I have 13 third root of 3s. Okay, last topic for example for 5.2, rationalizing the denominator. Okay, rationalize the denominator means you don't want a radical at the bottom. Okay, I have third root of 2 over third root of 5. If I could divide them, I would divide them. I don't rationalize unless I have to. Okay, since I can't divide them and neither of them come out nicely, I want to try to make this a nicer number at the bottom. Okay, since this is the third root at the bottom, I want 5 to the third to be at the bottom. Okay, I want to make this bigger. Okay, how many more 5s do I need to make this 5 to the third? I need 2 more, so I'm going to times by 5 to the second. Okay, if I do it at the bottom, I have to match it at the top. I don't care if there's a radical at the top, so I just put whatever's at the bottom. Okay, let's bring it over. So on the bottom now, I have the third root of 5 to the third. Okay, on the top, I have 2 times 5 to the second. 5 to the second is 25, times 2 is 50. And I times out the top because nothing good comes of it. Okay, now what do I got? The third root of 50 is not going to simplify because it's 2 times 5 to the second. The third root of 5 to the third is 5. Okay, so this is rationalized because there's no longer a radical on the bottom. Okay, let's try another one. Okay, B, it's the fourth root of 7 over 2. Okay, they've written it different, but this is the same as saying this is the fourth root of 7 over the fourth root of 2. Okay, now if 7 divided by 2, I would do 7 divided by 2 because I don't like to rationalize the denominator unless I have to. Okay, since this is the fourth root, I want this to be 2 to the fourth. How many more 2's do I need? I need 3 more, so I'm going to times by 2 to the third. Whatever I do at the bottom, I have to do to the top to match it. Okay, now on the bottom, I have the fourth root of 2 to the fourth. Okay, now on the top, I have the fourth root of 7 times, what's 2 to the third? 8. 7 times 8, I got 56. The fourth root of 2 to the fourth is 2. Okay, and then this is a better answer because there's no radical at the bottom. I guess try trickier ones. Okay, third root of 10 over third root of 49. 10 doesn't divide by 49 for sure. The other thing is I don't want to multiply it by 49 to the second power. So let's rethink this. I'm going to rewrite this. Okay, 49, I already know is 7 times 7. 7 times 7. How many more 7's do I need to make it 7 to the third? I need 1 more. Okay, if I do it to the bottom, I do it to the top. Okay, on the top, 10 times 7, I have 70. On the bottom, I have the third root of 7 to the third. The third root of 7 to the third is 7. Okay, and then this is supposed to be a better answer because there's no radical at the bottom. Okay, let's try D. Okay, 8 over third root of 25. Can't divide it. There's a radical at the bottom. The 25, I just staring at it, I know it's 5 times 5. So let's rewrite it. Yeah, or you could write 5 to the second. Okay, I want it to be 5 to the third at the bottom. How many more 5's? I need another 5. If I need it at the bottom, I need it at the top. But this is a third root of 5 and there's no radical, so let me write third root of 5 at the top. Let's see what we get. So 8 third root of 5 is just that. At the bottom, I have the third root of 5 to the third, which is 5. Okay, last one, which I feel like we were actually pretty good at. Okay, the denominator has a radical, but there's a plus and minus. So I'm going to multiply by the conjugate. 5 plus root 3, I multiply by 5 minus root 3. If you do it to the bottom, you do it to the top just to match it. Okay, we are going to times out the top. 7 times 5 is 35. 7 times root 3 is 7 root 3. Okay, on the bottom, I want to times all that out. 5 times 5 is 25. Now, if I do minus 5 root 3 and plus 5 root 3, they always cancel. So I'm going to skip the middle term and go to root 3 times negative root 3. It's going to be negative. Root 3 times root 3 is root 9. Okay, at the bottom, I have 25 minus 3, which is 22. Okay, and this is considered a better answer because there's no longer a radical at the bottom.